Okay. Thank you. Thank you. Please go ahead.
Okay, let me share my screen. Okay, so today we are going to start with data warehouse concepts. So in data warehouse concepts, first we wanted to understand BI. What is BI? What is business intelligence? Okay, so before I explain this concept, uh, usually right in real time, not even real time. So usually if any person who is having an organization, okay, so if it is a small organization or a small factory or small company, so which they are generating some kind of a products. Okay, if it is a small company or company CEO or MD will be having direct visibility that how the sales are going, how the people are working. Okay, so how the products quality is coming, and so what what exactly is happening with the sales of different regions. Okay, regions in the sense if it is a small company, the sales will be the local sales will be there. Okay, as soon as the company is growing, okay, number of manufacturing units will be more, and when the number of manufacturing units are more, so the number of products that are going to be generated also more. When number of more products are getting generated, the number of sales will be more. When number of sales has to be more, then number of locations that we will have to sell it. So usually, if any company is going to do the same process, so when they are doing the same process, okay, so for last year, how many sales have completed? For last year, how many employees were there? So what is the average ratio of sale to the average ratio of employee to the sale? Okay, so each employee how they are selling it, or on an average, how these employees are selling these products, or which locations where we have more sales for our products. Okay, so which region we have more sales in our products. Okay, or which region where we don't have proper sales, like all the products are still getting expired out in the same location. Okay, or so is there any new locations that we will have to open? All these things that everybody or any company will be thinking of, right? When they have to think of about all these decisions, what they have to do, they have to see the data. Okay, that means first of all they wanted to see their sales report, profits report, or losses report, or so what is the budget for this year, and what is the expenditure, and what is the forecast of next year budget. So to take that decision, what they have to see the reports. When they have to see the report, they wanted the data. When they wanted the data, they wanted to get the data from source. What is source? Application system. Okay, when the data is coming from the application system from different regions, we have to collide into a single place, and that we are going to place it on top of that data that we are going to generate. Not we, the business people are going to generate the reports. When the business people are generating the reports, so they if they wanted to see the losses of last year or last quarter, or when they wanted to see the profits of last year or last quarter, last 2 quarters. Okay, so they will not be having direct visibility to the database. Okay, people will not directly come to the database and see the number of records. Like they will not fire the queries, SQL queries. There will be a reporting system, so that they are going to use it to take this kind of pictorial representations, like pie charts, bar graphs. Okay, like the different reports that they are going to generate. So that which is a useful way of them, like easily understandable kind of a reports that they are going to generate. Okay, since millions of records will be there in the database, and the people, company business people like CEO or MD or CFO or COO. any people when they wanted to take any kind of a decision across the organization level. So they wanted to see these reports. Okay, according to the report, they are going to take a decision whether we have to start new stores or whether we have to stop some stores. Okay, however it is. Okay, however they wanted to take a decision, they wanted the data. That data they wanted in the form of sectorial representation. Okay, so this business intelligence, which is refers to a set of methods and techniques that are used by the organization for tactical and strategic decision making. Okay, so when they wanted to take any decision, so they wanted to see the data, and so in order to get the data, so how the data that is going to be stored in the database. Simply, there are 500 tables data that I am getting from source. I'm just going to dump it in the target table. So will that work? No, right? Because if simply dumping the data is not going to help. So we have to do some calculations and we have to load the data into the target table. Okay. So now when we have to do the calculations, right? So there are certain namings or standards that we have to follow. Okay. This business intelligence is going to refer to set of methods and techniques. Okay. So now the same, the data, whatever we are going to store, so that we will call it as a warehouse. The place that we are call it as a warehouse. Okay, so usually, right, in the general world, so like Flipkart or Amazon, any company, so when they're selling their products, okay, so the products when we are going to book in online, when they're going to when we are going to book it online, so the product will be somewhere in different location. What they're going to do, so for all these today's orders, they're going to take into a single warehouse. From that warehouse, they are going to dispatch to the different locations. Similarly, here also the same data that is going to store in the data warehouse. Data will be coming to a data warehouse. On top of the data warehouse, where the different kind of reports will be generated, which is going to be useful to take the decisions by the business people. Okay, data warehouse is collection of subject-oriented, non-volatile, time-variant, and integrity data. Okay, so based on this data, the reports will be generated. So these reports will be used to support the decision making or to do the analysis of the business. Okay, now OLTP system. OLTP system is nothing but online transaction processing. Okay, so whenever we purchase anything, so the data will be stored in the backend database. Okay, so whenever we fill up any form in the online, the data will be stored in the backend database. That we will call it as OLTP system, the database in which the application data is going to store, whatever the application that we are going to use it. So every application will be having a backend storage. Okay, so the database which is going to store in the backend database is called OLTP system. Okay, so that is going to store only the current data, and we will be creating Informatica jobs, which is going to be used to copy the data or transform the data or send the data to the target tables, and we'll be scheduling them. So in real time, we are not going to manually run every day. So we are going to schedule them. So like daily basis or weekly basis or monthly basis or quarterly or yearly. Okay. So like that, they we are going to schedule it. So yearly basis is very rare scenarios where we are going to schedule, but monthly, daily, quarterly basis where we are going to schedule our jobs. So based on the data usage. Okay. So based on the data importance. So if the data is very important, so sometimes they're going to schedule even every 2 hours also. I have a project where the jobs are running for every 5 minutes. Okay, so like that, so based on the business requirements, we are going to schedule the jobs. Okay, so that these jobs first they're going to pull the data from the application system, because in the application system, if you are going to store the complete historical data, so then it will take it's going to give the performance issues to the application because the backend storage is more. So then whatever the DML operations that the application has to do, so that is going to take more time. Because of that, so we should not keep the data in the data warehouse or OLTP system. Simply, we are going to load the data into the data warehouse. Okay, so the data in the backend application, right? So the application, some of the applications that they are going to store in the database, some of them are going to store in the flat files, some of them are going to store in Unix with the different file systems, and some of them are going to store in the SAP databases. Okay, so the data, right? There will be a lot of sources. Some of the data is going to store in MS SQL, Oracle SQL, like different databases where the data is going to be stored. So now we are going to read the data from the source. Source can be anything, but we are going to read it and process it. Because as I mentioned, OLTP system is going to maintain only the current data because performance degrades by storing the historical data into the OLTP systems. Okay, hence we are going to store historical data into the data warehouse. So now, before I go to the differences, what is data warehouse? So the data warehouse is basically, as I mentioned, so it is a subject-oriented, integrated, time-variant, and non-volatile data. Okay, subject-oriented. Subject-oriented meaning, so data gives data that gives the information about specific subject area. Okay, subject area meaning, so like all the sales data will be in one subject area, all the marketing data will be in one subject area, all the employee related will be one subject area. Okay, so these are all the finance related will be one subject area. So different subject areas data will be getting into a single place called data warehouse. So that's why the data warehouse is a subject oriented system where it is going to read all the different subject areas data and integrated. Okay, so as I mentioned, right? So the data from the application system will be coming in any sources. Will be coming from any sources like Oracle, Flatfile, SAP, any sources. But at the end, the target will be there in only one database. The targets will be in only one database. So that's why we are going to call it as integrated system. Okay, time variant. So all the data in the data warehouse will be identified with a particular time period. So for every table that we are going to load it, will be having an audit field, like created date, last updated date, or created by, last updated by. This kind of an audit fields will be there. So these audit fields will be keep updating, like when this record got inserted, when this record got last updated. Okay, so every record is going to be identified. So when exactly this particular transaction is happened, and then non-volatile system. Okay, so non-volatile system meaning, so data will be stable in the data warehouse, because once the data will come into the data in the data warehouse, that data will be never removed. So the data will be still there. But from the OLTP system, so the data will be removed as soon as it is processing completed. Okay, now we do also have a concept of data mart. So data mart is specific to one subject area. Okay, so there are certain companies, like small scale companies, where they are going to where there will be a client of a vendor. Okay, so those people, they are going to just process. Some people only process sales data, some people only process marketing data, some people only process financial related data. So that we will call it as a data mart. So data mart is smaller portion of a data warehouse. Okay, you can just learn this data mart and data warehouse differences. Okay, yeah. Any questions before I start with the schema part?
A data mart also will have a historical data now.
Yes, data mart is also the same, but data warehouse will be having all the different subject oriented data, subject areas data. Okay, that meaning, so one organization, one data warehouse is going to store the entire organization level data. So that means global data will be stored in the data warehouses. The data mart is for specific subject area. Only small scale companies are going to use them because it will be having a very lesser data.
Okay, Pastor.
Okay, any questions, anyone?
No, boss.
Chandu? Nirisha, Chandu?
No, Bhaskar, clear.
Okay, fine. So next is schema. Schema is basically it's a graphical representation of a data warehouse. Okay, so there are three different types of schemas that we have: star schema, snowflake schema, and galaxy schema. So in real time, in a data warehouse, all the data will be stored in the form of dimension tables or fact tables. Okay, so the data in the data warehouse will be a dimension model. So in the dimension model, the data will be stored in the form of dimension tables and fact tables. Okay, so in real time, where we'll be having source system, staging area, data warehouse. Okay, so in the staging area, basically it is going to be dump of the data which is coming from source system. It is just a dump, no calculations, no validations, nothing. Okay, but in the data warehouse, so now different sources data that we will be getting into a data a staging area. From staging area, that is going to be used as a source, and we are going to load the data into dimension tables and fact tables. Okay, so the data model will be built for built with dimension tables and fact tables. Okay, now based on the requirements, there are three types of schemas that we have. They are star schema, snowflake schema, and galaxy schema. So this is a pictorial representation or graphical representation of a data. Now, for example, what is star schema? Okay, star schema is nothing but a fact table surrounding by dimension tables. If one fact table surrounding by multiple dimension tables, that we will call it as star schema. Okay, because dimension tables are going to have master data, and fact tables will be having keys of dimension tables and measure values. Okay, now a fact table will be having keys of dimension tables. So the fact table surrounding by the dimension tables. So I'll explain later what is fact table, what is dimension table, what are the different types of dimension tables. Everything I'll explain later. But just for sake of understanding, star schema. So simple. So a fact table surrounding by dimension table, that we will call it as a star schema. That means every dimension table in the data warehouse will be directly linked to only the fact table. That we will call it as star schema. And snowflake schema. Snowflake schema is nothing but a fact table surrounding by dimension tables, and dimension to dimension there will be a relation. So for example, whenever I wanted to load a dimension key of one table into a fact table, but we don't have direct source to get the key of this particular dimension table. So then what we use? We use another dimension table to get the key of one dimension table. Okay, so a fact table surrounding by a dimension table, and if at all there is any direct relation with dimension and dimension, or any dimension table which does not have direct connection to the fact table, but still they are part of the data warehouse, that we will call it as snowflake schema. Okay, so this snowflake schema which is very much easier to maintain, but queries require more joins because each and every part will be separated. Like it's a completely splitted tables. Okay, so in star schema, we will be having different tables, and all the tables are direct connected. Okay, so here we will some of the tables will not be having direct relation. So when we don't have direct relation, then still we have to establish a join, right? We have to establish a join between these dimension tables, and then we'll have to load into the fact table. That we will call it as snowflake schema. Any schema, if you see fact tables surrounding by dimension tables, and if there is any difference when there is any relation between dimension to dimension, then we will call it as snowflake schema. And galaxy schema. So if a dimension tables or many of the dimension tables are surrounding by the many of the fact tables, many fact tables surrounding by common dimension tables, that we will call it as galaxy schema. So in real time, majorly we are going to use either snowflake schema or star schema. These are the two schemas that we are going to use it in real time. And so these schemas will be designed and developed by architects, but we should understand, we should have a knowledge of understanding it. Don't need to develop these things. We just need to have knowledge to understand, like if they say that this is a star schema, how this is going to look like. And if we say that this is a snowflake schema, then how it is going to look like. Okay, so at least minimum we should understand, we should be able to understand about these particular schemas. Now here we do have difference between snowflake schema and a star schema. Star schema is a simplest data warehouse schema. Snowflake schema is more complex data model than star schema, because why it is simplest data warehouse? All the dimension tables are directly linked to the fact table. That's why we will call it as the simplest schema. Snowflake schema is more complex because there are multiple dimension to dimension table relations are there. Multiple dimension to dimension relationships are there. So that when we wanted to load the data, we need to write complex queries to read the data from different tables or to join the data from different tables. Right. So as I mentioned, so star schema, since it is directly linked to the dimension tables, so it will be easy to write simple queries. Okay, but snowflake schema, we have to write complex queries and load the data into the target tables. Any questions here? Star and snowflake schemas. So this is completely theoretical part. We just need to understand what exactly this is, because we don't have any practical things for this. I'll show some kind of a diagrams. Okay, but so in when you go to real time, these are kind of a theoretical concepts. So you just need to, like, whenever you heard any word, so then you just remember the definition of these words, so that why they are telling this or why they are using it, you'll understand.
Yeah, Bhaskar, please explain the dimension table and the fact table. Then we can understand the above concepts.
Yes. I'll come.
Yes, thanks.
See, schema part, if you understand, that is good. That is okay. So then what is dimension? What is fact? What is dimension table? What is fact table? Okay. So all these things I'll explain. Okay. Now, what is a fact and what is a dimension? So fact is a numeric value that is going to, so numeric value that a business wishes to count or sum. Okay. Dimension is essentially an entry point of getting the facts. So dimension are things of interest to the business. Okay, that means dimensions are the master data. like all the product information is one dimension, all the customer details will be in one dimension. Okay, this is the master data, okay, which does not have any calculations. So like, do we have any calculation to the products? No. Do you have any calculation to the customers? No. Do you have any calculation to the countries? No, because this is the master data. This is essentially, it is required data, but this is not going to be used for calculation. Okay, and fact is a numeric value. So all the calculated values, whatever the calculations that we are going to do, all the calculated values, that we will call it as a fact. Fact is a numeric value which is going to store in the database. Okay, now what is a fact table? A fact table which is going to have keys of dimension tables and measures, calculated columns. What kind of calculated columns will be there? For example, so the number of products sold, the value of products sold, number of products produced, number of service calls received, and what is the average sales of last year or average sales of last quarter. Okay, so like this, all the calculated values will be stored in the fact tables. Okay, so the value that we are going to store, we will call it as a fact. So any calculated value that we will call it as a fact. Since the calculated values are going to be stored in a table, that's why we will call it as a fact table. So fact table will be having calculated values along with the keys of dimension tables. So for example, we have a fact table. So this fact table is having customer key, product key. Okay, so which customer purchased which product and when this product is purchased. Okay, and what is the sales, like, what is the cost of this product. So all this information that we are going to store it in one fact table. Okay, so now we will not directly store the customer name or the product name, because if you just store only the customer name, customer will be having more other details like customer name, employee ID, or sorry, customer mail ID, contact number, okay, date of birth, the address. There will be many columns will be there. So all this, so if the customer related information, if at all it is there in 2, 3, or 4, 5 fact tables, so we need to have all these columns to be mentioned in a single fact table. So instead of keeping all these columns in every fact table, so we are going to store all those columns data into a dimension table called the customer table, and that particular key that we are going to store with the fact table. Okay, that key we are going to store into the fact table. So we are going to establish a parent-child relationship between this customer table and the fact table, so that when we wanted to get customer details along with the fact calculated columns, we will establish a join between fact table and the dimension table. So based on this key value, so that we are going to get all the columns from dimension table, and also we are going to get all the columns from the fact table. So keys of dimension tables that will be used to establish a join with the dimension tables, or at what level the data is going to be stored in the database. Next is a factless fact table. So factless fact table is nothing but a fact table which does not having any fact, which is going to have only keys of dimension tables, which is going to have only keys of dimension tables. Okay, so usually we will call them as in real time bridge tables. So whenever we wanted to establish a join between two tables, but if at all we don't have direct relation between these two tables, so then we are going to have a bridge table between these two tables. Like, the bridge table will be having only keys of these two tables, so that when we wanted to establish join between these two, we can use this bridge table. Okay, now type of facts. There are three types of facts: additive fact, semi-additive fact, and non-additive fact. Okay, so semi-additive fact meaning calculated value. So the calculated value will be based on all the keys of the fact table. So when we wanted to generate a calculated column, so in order to generate that calculated fact, if you are going to use all the keys, then we are going to call it as additive. That means whatever the keys which are there in the fact table. So when we are summing up the value if we are going to use all those key columns in the group by class. If we are going to keep all the key columns in the group by class, then we will call it as additive fact. So additive facts are the facts that can be summed up through all the dimensions in the fact table. Semi-additive fact meaning those are so only some of the dimensions will be used. Some of the dimensions will be used to sum up to generate a fact value, to generate a fact. And non-additive. Non-additive is nothing but it is a manual calculated values. So from the application itself, we are going to keep the business people are going to keep the manual calculated values. So it is actually a fact that we are going to load into a fact table, but we are not going to calculate it. Business will be calculating it and directly sending it. So no other dimension keys will be directly involved to generate this fact. That we will call it as non-additive fact. Any questions here? Additive, non-additive, semi-additive facts.
Bhaskar, correct me if I'm wrong. In the fact table means that whatever queries, like before we discuss the joins, everything, right? Those kind of tables will be in the fact table, and the real time data will be in the dimension table. I mean, the dimensions, correct?
Yes, if you see here, if you see this diagram, okay, this is one of the fact table. So this fact table is having the data of dollar sold, unit sold, dollars cost. These are all the calculated values. Okay, so this is the level of data that we are going to store. So now, when we wanted to display the product information, we have this many columns. When we want to display customer details, we have this many columns. So is it possible to load this many columns or this many columns or this many columns into a single fact table? The fact table will be very much bigger. And if the similar key is present in another fact table, again we need to have all these columns. So in order to avoid to have the redundancy in the data, okay, so what we are going to do, we are just keeping the keys of dimension table. We are just going to keep the key of the dimension table. When we wanted to get the product information based on the product key, this fact table and this product dimension will be joined, so that from that query we are going to get keys of these calculated columns along with the product details. Okay, so one dimension table will be prepared for one master data, one kind of a master data, like all the product data, all the customer data, okay, all the stores data, all the clerks data, all the time data. So for different set of master data, we are going to have separate dimension tables.
So, Bhaskar, here, can you give one example for which is the additive, semi-additive here?
Yeah, here, right? So these are the keys of, so the until here, starting from here to here till promo key, these are keys of dimension tables. These three are calculated columns. So in order to generate this calculated column, if you are going to use the combination of all the key columns, if you are going to use the combination of all the key columns, then it is an additive fact. Okay, this is a fact. This dollar sold or unit sold or dollar cost is a fact. When we wanted to generate a fact, if we are going to use all these columns in the group by class to generate this, then we will call it as additive fact. Semi-additive fact, only few columns that we are going to use. Only few columns that we are going to use it to generate this fact. That we will call it as semi-additive. So now this information is directly coming from source itself. We are not doing any manual calculations. Okay, that we will call it as non-additive because we are not doing any calculation through our ETLs. Got it? Fine. Understood? think